yeah, for this video I'm going to recite the given task, which is the elements from number 1 to 50 and their symbols and the names. So first, we have hydrogen, which stands for H, and He is helium, Li is lithium, Be is beryllium, B is boron, C is carbon, and N is nitrogen, O is oxygen, F is fluorine, Na is neon, Na is sodium, Mg is magnesium, Al is aluminum, Si is silicon, P is phosphorus, S for sulfur, and Cl is chlorine, Ar is argon, Ke is potassium, Ca is calcium, Sc is scandium, Ti is titanium, and V is for vanadium, Cr is chromium, Mn is manganese, Fe is iron, Co is cobalt, Ni is nickel, Cu is copper, Zn is zinc, and Ga is gallium, and Ge is germanium, As is arsenic, and Se is selenium, Br is from bromine, Kr is krypton, and Rb is rubidium, Sr is strontium, and Y is yttrium, and Zr is zirconium, and Nb is niobium, Mo is molybdenum, and Tc is technetium, and Ru is ruthenium, Rh is rhodium, Pd is palladium, Ah is silver, Cd is cadmium, and Ni is indium, and lastly is Sn is tin. So, questions number 2, state the difference between atomic mass and atomic number. So, the difference between the atomic mass and atomic number, the atomic mass is the of an atom is a chemical element that is expressed by atomic mass units, and it is approximately equivalent to the number of protons and neutrons in the atoms. So, mass number, or to the average number of the allowing for the relative abundance different isotopes, while the atomic number or the proton numbers, which is symbolized by Z, and it's a chemical of element that is a number of protons found in the nucleus of every atoms of the elements. So the atomic number uniquely identifies a chemical element. So questions number 3, point allocations metals and metallism periodic table. So as you can see in my pictures here, that we have the pictures of periodic tables that is divided into 3 colors. So we have the sky blue, which is the metals, the green which stand for metalloids, and the yellow is non-metals. So they are divided into 3 different colors, which is the metals, metalloids, and non-metals. Questions number 4, differentiate the properties of elements that are categorized between periods and groups. So as we all know, in a periodic table, which is we can say that there are columns right in there and the rows. So they have difference because and vertical columns are on the periodic tables are only called as a groups or a families because of their similar chemical behavior, and all the members of the family of elements have the same numbers, valence electrons, and similar chemical properties, while the periods in a horizontal rows are only called as periods. So in question number 6, enumerate and describe the characteristic of each family groups in the periodic table. So as we all know that in the periodic tables we have they are divided into 3 parts of groups, so which is the metals, the non-metals, and the metalloids. So metals are the bottom of in the bottom of the 2 rows beneath the body of the periodic tables are the lanthanides and the actinides, which are also metals. Properties of metals Metals is also shiny and solids, a room of temperatures with characteristics and high melting point identities. So the non-metals, on the periodic table, non-metals are located on the upper side of the periodic tables. Properties of non-metals have the high ionized, energized, and electronegativities. They are generally poor conductors of heat and electricity. While metalloids, the metalloids can be found typically, and metalloids have metallic appearance, but they are some periodic tables have dividing line between metals and the non-metals, and also and below this usually brittle and only mediocre electricity conductors chemically. These elements usually behave as non-metals. Metalloids have the ability to form metallic alloys. So in questions number 5, point the locations of the orbital shells, blocks, the SPDF, and so in the periodic table, so we can see that when we facing the periodic table, so the S blocks here is from hydrogen to helium. So these are the S blocks, and also from boron to neon. So these are the P blocks down to the number of 118. So this is the P blocks, and also from the number of from column 3 to column 12. So these are the D blocks, and also the F blocks. So as we can see in our periodic table that lower part, so there are separated elements here, that is this is what we call as F blocks.